Hello, everyone, and welcome to the MLIR Open Design Meeting. Today, we are going to discuss side effects and semantic equivalence and how that pertains to special operations like Linalg index and vector mask. We have a presentation by Carl, and we'll probably get into a long discussion after that. Thanks, everyone, for joining, and Carl, the floor is yours.
Hi, thank you for having me. This is a discussion that has been burning in my chest for a while, and it seems like everybody has kind of different expectations, and I'm not very adept at expressing it in writing. So I made this short presentation. It has 4 parts to it. We can stop and interject at any point we want. I want to start with what the issue is we've been seeing. Then I want to show why that is happening. And then I want to go into the 2 things I mentioned, side effects and what semantic equivalence is in this context. So to recap what we have observed, the first thing here, this is MLIR slide where I removed types and stuff. If you make a program like on the left with these 2 nested Linalg generic ops and add those 2 Linalg index ops and you run CSE on that, it will incorrectly conclude that J can be replaced by I. I say incorrectly because if you look at the definition of what Linalg index is supposed to do, that would contradict that. There's an argument to be made that nesting Linalg generic ops should be undefined behavior. I think this is somehow an issue I'd like to shelve. That seems to be another can of worms, and I would only like to reference that in the documentation for Linalg generic, it doesn't explicitly say that, so I hope I'm forgiven for trying this out. We can still produce a similar issue with something where we don't have to go against common knowledge. So Matthias Springer found this example where the vector.mask operation will have the same issue. I slightly modified this one to fit it on the slide. I used this add reduction over arg0, and on the left program you can see one happens outside the mask, the other one within the mask. And if you run CSE, you will get the thing on the right where it incorrectly concluded that the result could have been replaced by the outer reduction. And obviously that's not the same. The outer reduction is just a reduction. Inside the mask, it's more of a dot product with the mask. This is also not expected behavior, I'd argue. I pasted a little bit of the documentation down there. So those are 2 issues we can receive and right now reproduce with upstream MLIR, and it seems like semantic equivalence is broken here. So those are the 2 examples we've had in the thread. We have some more with fixes later. So the next question is, why does that happen? So we'll have a very quick look at what the common sub-expression elimination is doing. That's a pass we have in MLIR that is quite generic. And the way it works, it just walks your IR and tracks all of the definitions that are potentially available to whatever scope it is you're walking in. So it deals with dominance and region isolation and keeps track of those. And it does that so that whenever it counters a new definition, it can try and replace it with an existing one. Even with the operations we just looked at, it can do useful and meaningful things. There's just an example on the right where for Linalg.index, it can correctly conclude that those 3 things in green are actually the same equivalence class, and you can replace all of those with the first definition. And that even works outside of region boundaries for those pure ops here. Why can the CSE decide to do this at all? Right? Here we need a little bit of a model of what this equivalence stuff is. And so we've already said it tracks the existing definitions and it looks at the isolated scopes and everything. What it needs to do is it needs to exploit that the operation does the same thing. If you think about it in a functional way and remove any implicit state, then every operation is some sort of function with operands, which are the operands, and some more operands we don't see, which are these implicit state dependencies. And those functions are somewhat pure in a mathematical sense in our model, meaning that if you have the same function, you have the same state, you will get the same result. And you can exploit that. So for CSE to do this, it has to prove 2 things. It has a candidate of an existing definition and one that it wants to remove or replace. And it has to determine those are semantically equivalent, meaning if those 2 ops are executed on the same state, or you apply those at the same state, they will do the same thing. In other words, they're the same pure mathematical function. It does that using operation equivalence, and I've highlighted in red where that happens in this part of the CSE code. That happens in its value lookup. And the other thing it needs to do is it needs to prove that when you reach that point, the state that those two ops observe is the same. So that it's actually acting on the same data. And that it does by following the memory effect op interface. Okay, so this, in my opinion, is sound logic. This is applicable, so why do we get the problem? Well, clearly we get the problem because those two things apply where they shouldn't. So for Linalg.index, we see this definition of Linalg.index in ODS, which has this pure attribute. And pure implies no memory effects. And we also see that there aren't any SSA dependencies that we create or anything else that distinguishes these two Linalg index ops in our counterexample semantically. So crucially, this thing does not model that there is any dependency between Linalg index and the Linalg op that's surrounding it, right? And therefore, it can't be detected by CSE, and it concludes that it can be replaced even though it can't. For vector.mask, we have a similar issue, except that masking is expressed using interfaces everywhere. So we have the masking op interface and the maskable op interface with this dependency. Again, that's not modeled in ODS. If you look at all the operations that currently implement maskable op interface, none of them have any dependency there. It's a little bit more complicated than that, because interfaces we could attach with external models, and that would mean we'd have to inject side effects also into things we would like to attach external models to. So it feels like this would be even harder to solve, but it's the same issue. You can see for reduction, for example, it's also declared pure. This dependency isn't modeled at the moment. So that's the part of why that happens. Do we have any questions we want to address so far? Because I hope that's the point where we all agree. Yeah.
Yes.
I mean,
yeah, go ahead.
No, I mean, perhaps one question. I mean, we talked about like the Linalg op pure, but pure also is defined as having a different property of being always speculatively executable.
Also that, yes. But that doesn't matter for what we just looked at. The CSE doesn't evaluate this. I have something on speculability too, but that doesn't matter for any of the code we have right now. Yeah.
Okay.
Okay.
I'm just wondering, like, even like the definition of it being always liftable in versus being conditionally liftable for the index op. But if that comes later, then we could discuss later.
We can do that later, but it's a good point, obviously, because you can lift the index op out of SCF force or something inside your Linalg generic, but you can't lift it out of the Linalg generic, for example, right? But technically, you don't have to solve it with speculatability. I'm now getting to the side effects. They will also solve that if you correctly apply that. So with side effects, I don't actually want to explain the whole side effects thing again. There's a good talk you can look at. There's also recording from 2023 when things were called side effects and not memory effects. They've been renamed, but they explain to you how the infrastructure works. I just want to give you one slide to summarize like my view of that. Basically, we have a very generic mechanism with which we can model these implicit state dependencies between ops. I phrase this in a very roundabout manner because what I want to make certain here is that this only applies to code where you already have some control flow. It hardens dependencies to true dependencies that are only incidental. So you have program points in your program, and by introducing memory effects, you can introduce true dependencies like data flow dependencies, so read after write and write after write, to indicate that the order that these ops are in currently is important for correctness, right? That's what true dependencies in data flow are. You can't violate the order or you change the correctness of the program. But it does follow the model that there is control flow. The only thing that goes against that is the current side effect interface can also have effects that act on the whole block or something, which could technically go back in time or whatever you want. So that's what side effects can model. You can model these dependencies and you would obtain them, theoretically speaking, the whole reasoning power of that model. You would do a data flow analysis on your program point lattice, and then you'd figure out all of those dependencies. The CSE currently only conservatively approximates that. So it pessimizes this, but it could do this to a higher granularity. So with these things, you can model any dependency you want in control flow that's parallel to control flow using read and write side effects. There's obviously also alloc and free, but let's ignore them for now. So you can model any you want. And that means you can, of course, also model one between your Linalg index op and your Linalg generic. So first of all, to make them not semantically equivalent, these operations, we now have to say that linalg.index is observing some sort of state that isn't shown in the IR directly. I get to the question after the slide. Is that fine? Yeah, that we don't see directly. So we add a memory that would, to our mental model, add that there is a resource that this thing is querying. This would immediately fix the issue, but obviously not sustainably, because we actually haven't added a true dependency between the parent and the child. It's just CSE is overly conservative. You can do this on resources and stuff. So technically the parent could provide a resource so that it doesn't interfere with anything else. Before I move to the next slide, Matthias, please, your question.
Yeah, I didn't quite follow the thing you mentioned on the previous slide. So with the dependencies, what exactly, I mean, why is a side effect, why is that, in what sense is that a dependency? What does it depend on?
Oh, it's an ordering dependency between ops. So if we model memory side effects to read and write stuff, right? And we want to use that to reason about program correctness, then the model we have to use is somewhat how you can interact with the state, what you can query from it. And therefore, all of the correctness dependency or the constraints to correctness of our program schedule are results of true data flow dependencies. So putting something into the state, the implicit one, and then taking it at some later point, or overwriting something in the state and therefore changing what you would observe later. So these are the two types of true dependencies that would change the outcome of the program, the observable one, if you change the ordering. And my argument here is that that's the expressive power of the side effect model. No other conclusions can really be made from it until you add like alloc and free effects. If you have different opinions of what it should also do, I think we should discuss this. But in my view, that's like the most underlying thing you can do. Does that somehow answer the question?
Yeah, so okay, my understanding is there are two kind of dependencies. One dependency is you look at an operation and it has operands, and you trace it back. That's one kind of dependency. That's directly
SSA, yeah.
SSA.
Yeah.
And the other kind of dependency is you have side effects, and that's is kind of like a state that you modify, and you cannot move operations around because you would change the order of the side effects. So that's kind of like another kind of dependency, but it's not visible in terms of SSA, but in terms of the kind of state.
Exactly. And like, there's stuff like in LLVM, there's memory SSA analysis where you turn this into SSA dependencies. So you want some granularity over your state, but it leads to the same thing, right? And that's why I say these are the information you can extract.
Okay.
So yeah, so you can add a read to index op, but then you don't have an actual true dependency between the index and the parent, saying the index has to be in or after the parent, which is the one we need. So you also have to add some write side effect to the parent. So here you could go into the generic effects impl and add some write side effect to the resource that you want there. Now there is an outstanding problem here, which is I don't actually know how ordering and scoping of memory effects works in region branch op interfaces. So how can you say that some of the parent's effects happen before the stuff that's recursively in there and then after? But I'd say that's just an implementation detail or whatever. We can definitely fix that. Maybe it already works. The point being, you then have these true dependencies between the parent and the child. And then anybody who does the proper data flow analysis would conclude, of course, the child can only come inside or after the parent, right? Yes. This has a couple of adverse effects if we do this right now. The first one is because the containers we have, vector.mask and linalg.generic, have recursive side effects. We'll now have new side effects leaking out, the read effect and the write effect of the parent itself. That's, in my opinion, not really a long-term issue because those are not spurious side effects. Like they are true dependencies. You just have to get your analyses up to snuff so that they can deal with them. Currently, things we would pessimize are CSE, and loop invariant code motion. So if you do this if you add a read side effect to a vector.transfer read or whatever, it's going to be very sad. You can't lift it out of an SCF4 anymore, but that's just because of how conservative we are at the moment. Another thing you do though is you do need to have a write side effect at some point to get a true dependency. And if you add a write side effect to an op, you prevent it from becoming trivially dead. It also pessimizes DCE, and it subtly impacts other points too, because trivial deadness is a little bit privileged. So for example, dialect conversions can now become illegal because illegal ops that are trivially dead, right, get automatically removed, those kinds of things. So you have a couple of adverse effects, but none that you couldn't solve with more patterns. Now it gets a bit more esoteric. I want to say that solves problems we have, but it doesn't address other problems we might have in the future. So the first one is, of course, we're going to have to implement a lot more interfaces if we have to model all those things with the side effects. And there's no way to inject side effects into somebody who already declares them. So there's no really good way to find a way to add masking op interface or maskable op interface to an operation where they're an external model, or prevent someone from foot gunning themselves and forgetting to add the effects. So this seems to be like the most pathological case where you have to inject new effects if you want to use the model, the interface, model the interface. But man, that's a design issue. Interestingly, there's no way to prevent CSE from modifying the use list of an operation without adding a right side effect. Sounds a bit weird, was in the thread. The point is basically, if you don't have a right side effect, your CSE can always conclude, oh, I can decrease the number of uses on this app and increase that on that one. That doesn't sound like a problem until you use these ops for witnesses or something where you want to have an invariant which says, oh, I only use this once. I have an upstream example of this at the end, by the way. And the last thing is, there are things where you need to add those side effects to get them to be modeled correctly, but they are spurious in the sense they're not really there. So if you have non-deterministic operations, which I don't know if you want them actually, but if you had them, you would have to add the side effects to make sure they don't get moved around in the wrong way, but maybe they are still independent and you can't have that anymore. And finally, because memory effects follow control flow, you can't do stuff that doesn't do that. So you could have dependencies on things that happen after you, right? That sounds a bit weird from an execution model, but using MLIR as just a general model, or controlling like code generation by ops that are consumed during lowerings or whatever, you could have this. You could have an op that says, give me this, in this register, materialize the stack size of the function I'm in. Weird. Wouldn't be that hard to write in many cases, but that's not a dependency you can model with this. Question, do you want that, right? But you can't do that. So before I continue, questions, right?
Hi, yeah, I was wondering, in the case of Linalg index, if it's not enough to just implement the dialect fold interface to prevent the Linalg index from being hoisted outside of the Linalg region, and then that would prevent I guess that doesn't fully capture the side effecting of it, I guess.
It doesn't, and it also doesn't prevent what the CSE currently does, because the CSE doesn't consider this hoisting, what's happening there. It also doesn't consider that speculation. It sees it's an available expression from the outside that applies inside. So that alone wouldn't be enough.
Okay.
One thing
yes,
about what you were saying, not on this slide, one of the previous one, I forgot.
sure.
You said that for recursive side effects, ultimately it wouldn't be a problem because it's just a matter of figuring it out with the data flow.
Yeah. Oh yes.
So in general, it's true, right? We can always figure out, but it can be non-trivial.
Oh yeah.
In the sense that there is value in, for example, the predicate that op trivially dead, and those kind of things that don't require, that can answer locally. Like I look at one Linalg op and recursively, what everything that contains below, and I can decide.
Yes.
And it's not something for which you want to do complex analysis. So a solution, just to say, correct in general, there's also a dimension which is like having the ability to encode those kind of information directly in DIR in a readily available way is valuable.
Yeah, I completely agree. And that's also why I think that conditionally speculatable exists. Because my argument kind of is that it's just an ordering dependency, and you could model this using memory effects. Sounds a bit weird, but you could make like a speculation hazard resource or something, and you could add all these control flow dependencies that arise from this using that. But we don't, right? Because we don't want to add more interfaces, add more reasoning, add the required to do data flow reasoning, because we can describe these effects differently. I'm a bit
in terms of the data flow analysis also, right?
Yeah.
To be able to figure out things, if we look at the relationship between a Linalg op and the index op, right? There is like
Yes.
the private channel, and the Linalg op writes to it, and the other one consumes from it. So there's a write and a read. But this resource
is scoped to that Linalg already. It doesn't go out, right? Yeah.
Exactly. And we don't have scoping right
No.
now.
Well, you can kind of hack it. So because you can just remove recursive speculatively, which is a bit bad, and just implement, recursive speculatively. You could remove recursive side effects, implement get side effects yourself, and just always call all of your children to populate your side effects. And then at the end, filter out the ones you didn't want to escape your scope. But that obviously increases the computational demand, and the non-functional properties of MLIR are like negatively impacted, like in terms of memory and everything. So you can kind of hack this, but I think that would be enough to show how that would work.
So I mean, I know this is a slightly sidetrack, but I'm just thinking about like other ops where we have like this index behavior. Oftentimes, it's passed as the first argument.
Oh yeah,
Right?
yeah.
So
I have actually. I get to that in the second way of fixing things.
Yeah.
But yeah.
One thing about what you were just saying, filtering, it's not clear to me that it works actually, in the sense that when would the write effect of the Linalg op show?
That's what I said earlier, right? If you consider the region branch, what's the order in which those effects happen? I think at the moment you can't have the Linalg generic effect have a write effect that happens before its children and one that happens after it. I think
there is a way to specify an order of effects.
Yes,
Like
but only on the operation you're on. The recursive effects are collected differently. They don't go through the same method. Recursive effects.
So exactly, and like doing a manual equivalent of recursive effects will let you do that.
It will let you do this. Yes.
Then you can put that.
And you can.
Sorry, to me, I was not pointing an ordering effect. I'm pointing a scoping effect, which is.
Oh, yeah.
When you look at the Linalg op in its context, in its parent block, you want to say that it doesn't have any effect.
Yes, exactly.
But when you look at the Linalg op itself and its region, it has a write effect on this private resource.
Yeah, depending from where you walk it. Yeah, like there would be an entry program point to the op at which you have that effect, right? Or something. Like in the region branch at the beginning of every region there would be effects coming from the parent.
Right, and those are not a get effect on the op itself anymore.
Yeah, that doesn't work. So yeah, we
can
can't
that somehow
quite do this.
Can it somehow be solved by like pretending it's allocated and freed at the end or something like that?
Yeah, but then from the outside, you still see alloc write free, and you have to reason about the fact that you can ignore the write because it's a write to something that is freed at the same time.
Yeah.
It's like if you just want to look at every operation and says, like in a block, does this op write to memory? You will still get yes, this op writes to a memory that it allocates itself, but and free after.
You can't do like the little check that says has no memory effects, which we kind of want, right? So the speculatability also exists. The documentation kind of implies there are other side effects. The only thing I want to make clear on the slide is no. So if you have any implicit state or anything, you cannot model this using conditionally speculatable. You have to model it using memory effects. Otherwise, it will be ignored. The CSE also doesn't look at that. I think the only workable definition I really have for speculatability at the moment if something is not speculatable, that implies it's not hoistable. And it's only that implication that I can currently see. But so this doesn't solve any of the problems we have. But yeah.
Why do you say that? Not speculatable implies not hoistable?
So the thing is, the only way speculatability is used right now is in things that do code motion and that do loop invariant code motion and hoisting, and they check that the op is speculatable. And if we look at the definition, right, it's about side effects like trapping, or if you look at the rationale document, about like exceptional control flow, like you get stuck in an infinite loop or something. So the point of not speculatable is to indicate that if you do this at a different point in the program, you're no longer guaranteed that you'll ever get out from there and see any of the other operations. So it imposes an ordering dependency that if there's anything in the state you want to observe that comes before it, and you move that before it, you might not observe it anymore. So that's kind of the dependency it has. And so therefore, the only thing it is used for at the moment, or where it matters, and which is also why it's not used in CSE, is to determine if I can hoist something out. Because if I hoist something out of a loop, I might only execute it once instead of 15 times. And so obviously the other 15 state iterations I wouldn't see. So the only thing that it currently does reliably is it prevents that.
Yeah, I'm a bit confused. Like, first, the difference I would make between speculatable, what's the difference you make between speculating and hoisting?
Oh, so for me, speculating would mean something. If I have an op and I speculated, that means I can now see a program trace where it happens at a different point in the trace, or even leaves the trace. That is what would be speculation for me. Speculating implies that I can move it at an earlier point or not at all. That's what I think speculation means.
And so what, okay,
In hoisting,
I understand it differently, but let's go with hoisting.
Oh, and hoisting would be, it goes to an earlier point. It can't disappear, but it can go to an earlier point.
Interesting. So to me, speculating meant that you would execute it, you would see it on a program trace where you wouldn't see it otherwise.
Oh, where it couldn't, yeah. Yes,
Meaning,
yeah.
Meaning, whereas hoisting is just executing, outside of control flow, outside of a loop or something. But if you take an operation like CSE will frequently do something like you have an operation that is on both the then and else branch.
Yes.
And we would, move it up, executing it early, but it would have been executed either way.
But that's not what that CSE does not do that. That's not CSE. You would have to, that CSE only goes down there. There are other parts, like there's control flow syncing, of course. There's loop invariant code motion that does hoisting in, I guess, what you define as hoisting, you move it out of control flow. But moving outside the SCF if, that's different.
Isn't what I'm surprised, like, isn't what you were showing with Linalg index or the vector mask things what CSE does, which is kind of moving?
Yeah, it is, but it requires that that definition is available. So if you have the thing like in both the SCF if branches, it wouldn't determine that it can do it before. It looks at only some stuff that
I
already
can
exists.
confirm that it doesn't because downstream we added the pattern to do exactly that.
Yep.
Makes sense.
So it doesn't. So according to the definition that I think most people have, the CSE does not speculate because of this, because it doesn't make something appear on a path where it wasn't before. It's always already there. CSE only takes something that's the dominator and uses that. I still think that's, from my definition, that's still speculation because it disappears on a different path, but that's just semantics. I think it's just a bit confusing to me.
All right, let's move forward.
Okay, so the second part and the last part is, right, the other way we can fix this is we can make the other check fail, right? We can make them not be semantically equivalent. Again, that would be the CSE cannot conclude that those two operations will have the same effect on the same observable state. So the first way to do that, the way that is checked is operation equivalence. Operation equivalence is written on the right. I snipped out the code. So you check, is it the same pointer? Then it must be equivalent. In all other cases, it does what I called op state equivalence. So it checks if the in-memory representation of those two ops is the same. So it goes over all parts of its state. There's a little exception for commutative ops, which is interesting. The CSE uses this, and it says that operation equivalence implies ops are semantically equivalent. That's the determinism we need, right? And we can't override this behavior. So how could you use this to your advantage to fix the issue we have? Well, for the Linalg.index, you could make an operand and model this as an SSA dependency. So the Linalg generic as its block argument would have to have its index tuple somewhere, and you pass that to Linalg.index. Now, two instances of Linalg.index are only semantically equal if they work on the same value. You get all the benefits. You've essentially removed the implicit state and turned it into an explicit one. I would call this like the RVSDG view of MLIR, where we remove all the implicit state and we have state edges, whatever. You can do the same to vector operations or maskable operations. You just have to have all of them capture an optional mask operand. That may not be desirable. So there's actually a second way to do this, which is to use something that looks like a witness, which I've done on the right. So you basically split the def use edge here for the operand. Instead of passing the mask and the operand to the reduction, you still pass an operand, but there is this mask operation which tells you this is the masked operand. You don't have to change the type either. The op isn't pointless. It can't just be removed. It will stick around and you will find it. And you can still piggyback off all of the other optimizations we had before. CSE will work correctly, lifting will work correctly, whatever. Might make the lowering a little bit more complicated because you have to look like outside of the scope you're in maybe, but it's fine. So this is one way of getting this to work. I still argue though that that's not enough, right? So we still don't have a way to prevent CSE from changing the number of uses on operations we have without adding write effects. I'll get to an example. We still can't compose control dependencies that go against control flow with regions there are, because those that go against control flow, we cannot model using SSA, right? Because we violate dominance. And operations that are non-deterministic or unitary, right, or something else, we have to add write effects which might unnecessarily pessimize them still. So because those are all kind of weird abstract concepts, I got a upstream example for you. And that's thanks to Maximilian, right? In IRDL, which is the language we can use to describe ODS, we have type constraints too. So we can build these ODS type matchers. And that's a conceptually pure language. You just make up a type matcher, but not everywhere. If you look in upstream IRDL, you'll see that something like IRDL any of op is actually not pure. And there's a reason for that, and that's CSE. So let me show you the example. You take the left program in IRDL, which matches somehow the right ODS specification. So you have this new operation, and you have two operands, LHS and RHS, and they take an any of. So what this says is you have two operands, each of which is either I32 or I64. So you get to choose two types. That's what you get on the right. If these operations were pure, IRDL any of were pure, so in other words, they are semantically equivalent, then you would get this, which the judgment that the IRDL is are the same is true. They match the same type, but the judgment that the IRDL any of are the same would be wrong. You would get this instead, where now you have an operation with two operands of the same type, which is either I32 or I64. And that is because the way that this is modeled here, the IRDL any of is somehow implicitly introducing a type variable or type symbol. And during unification, you decide whether those are the same or not, or coincidentally, but they're not semantically the same. In fact, any two instances of IRDL.any of in any program are not semantically equivalent. None of them are. It's like unitary. And if you model any other kind of type systems or similar to that, you run into the same issue. Yes, so that's an example where in upstream they had to forego this pure because of this particular property. So there might be another way to solve this. We say operation equivalence is great and all, but it doesn't imply semantic equivalence. So either the CSE also has to check that that holds, or we change operation equivalence to actually imply semantic equivalence. And then we could express stuff like I wrote here. So Linalg index ops are only semantically equivalent if their closest ancestor is the same. The same for maskable op interface, and the type variables, they are never equal unless they're the same pointer. So this has drawbacks, I'll get to them. One way we could do this is we could add an interface to override how operation equivalence works. I remember that this was ruled out back when this was made. I don't remember why though, so I would like to discuss that. But the way it would work would be very simple, right? You'd say pessimistically, no things are equivalent unless they implement this interface. The default implementation is whatever we're doing right now. And then we could even add like convenience traits, like always speculatable, to implement behavior like this scoped stuff we just had. This addresses all the functionality issues, but not the non-functional goals of MLIR, like memory usage and time. We need a lot more interface implementations. And also, as the only thing that I've proposed so far, this is not introspectable. So you can't actually tell if something is not equivalent, why it's not equivalent. And that's the downsides. Arguably, because you can add arbitrary verifiers to say whether two operations are structurally valid, maybe it's meaningless to have this introspectability, but you lose that. But you also lose other stuff. So if you operation clone, you're no longer guaranteed to end up with equivalent ops. Technically, you don't do that at the moment either, right? The IRDL, any of you, they are not equivalent. You just have no way of telling. But you also add all this overhead, and we get into the same problem where if you remember the is commutative exception, technically that's something that the commutative trait is adding to make the check better. So probably you don't want to return a bool, you want to return a maybe, yes or no, and this thing could preserve a maybe, or I don't know. So you could have something that works like verify trait or fold trait. You'd have something like equals trait. But this is, of course, a huge amount of infrastructure and also a completely new, although we use it already, dispatch mechanism. So I argue somewhere in between, we'd have to find a solution, because I really do think that at least unitary operations we want to model, even though they're not introspectable. And to summarize what I had, that's the end. We know that Linalg index and vector.mask are incorrectly defined at the moment. We have to do something. There just isn't a dependency. We also know that we can't have any implicit references to states in ops that we don't model with memory effects. They all need to be memory effects. And even though the existence of a generic side effect infrastructure and the documentation of the speculative trait implies otherwise, that's not the case. You have to use those. I would like to have proven, hopefully to you, that some ops suffer from over-approximation with the side effect model, but we could solve those if we harden semantic equivalence in MLIR somehow. And then finally, what we had earlier, we probably need to look again how to make the good data flow analysis for memory effects where we actually want the good results. We have to think about how to order effects in region branch regions, and probably we want to have a mechanism to scope effects. So I hope that's the takeaway we can agree on. Okay, that's the presentation.
Awesome, thank you. I think so. We had a very long discussion on the forum about this, so it would be nice to make some tangible progress. I think there are many problems here. One, I would point out, is we have operations that are indeed incorrectly defined or have weird semantics. Another one I would add is GPU thread ID and block ID.
Yes, that was good.
Exactly the same relation to GPU kernel as Linalg index has to Linalg generic.
They're also unitary, right? So if you copy a barrier somewhere else, you have a different barrier now. You can never get the same barrier again, right?
That is also true. So there is a bunch of those, and we had like a long-running discussion on semantics of barriers with respect to side effects as well. So this sounds like something that needs an immediate fix, but I think if we can get some better understanding of what is the solution that has the best trade-offs for us.
There is so the GPU thread ID and this kind of thing, or index, I forgot how they're named, are kind of walking that, because if you look at the execution from the point of view of an isolated kernel or function, right, and you look at the function like its own standalone program execution, then those ops are reading a constant of the program that you don't know, that's just set before the function starts. But
yes, but we could have nested kernels. We actually have a downstream with nested kernels.
Okay.
A kernel launches another kernel. And it's exactly the same where the thread ID that you call in the nested kernel that's called dynamically from another kernel could be CSE'd away to be the thread ID of the surrounding kernel.
If you're using launch kernel instead of launch func, that's what you're saying?
Yes, if I'm using literally kernel that has a body, not the like launch GPU.launch, not GPU.launch func.
Yeah, exactly. That's what I was saying. Yes, launch is broken from this point of view. Yeah, you're right.
Is launch broken or is thread ID broken, right?
I mean, not
The
thread ID.
relation between the two.
Yeah.
I'm not pointing at thread ID because in the context of launch func, there is no problem.
Yes.
Right. So thread ID works fine in the context of a standalone kernel. It doesn't work when we use the region. And that's because we have the same problem as we mentioned before with the Linalg op. You have to look at it from the outside, from its context. Whereas a function is an isolated execution unit to some extent. So that's why it's work. I'm not saying it's perfect, but in general, that's why there's not the same problem when the relationship is between a function and an op.
But I think masking is the worst offender here because Linalg generic is also usually not nested.
Don't make assumptions about my pipeline. I worked hard on it. Yeah. No, but I get it. Yeah.
We can the previous slide. We're asking about why why don't we exclude an interface? I forgot which one.
I think this one, I remember when operation equivalence was introduced, which might have been 2 or 3 years ago, maybe even longer. I think 3 years was probably, that there was a discussion of, oh, how should we have a mechanism to override this? And I remember the judgment was we shouldn't. It should be a simple thing. But now it has the commutativity exception too. So it already does on operation star, has traits, already a linear scan, right? So I don't know.
So the problem is not a matter of implementation. Scan or whatever. The problem is more a design one in terms of what do we want for MLIR semantics. What is part of the semantics of MLIR, and upstream, and what is just left to people to define, right? It's like take SSA for example, right? SSA is a thing. We don't let people get out of SSA. It's pretty core to MLIR.
Oh no, graph regions are a thing.
Even
yeah, you have SSA, but you don't have dominance. Sorry. For me, SSA means there's also the dominance property, right? So
correct. Indeed. And at some point, like at the beginning, by the way, at first, MLIR didn't have anything else than CFG regions and nested.
Yeah.
And getting graph region was, took time to get there because those are the kind of design trade-off about what are semantics we want to do. And actually, we didn't make the region totally open. We just define what is a graph region, and we're like, there are two different kind of region. You are either in this case or this case.
Yeah.
And it's the same for many other aspects, of MLIR, where we're like, we put constraints because we want to reason about the program in one way, and as much as possible, of course, within the constraint of MLIR being extensible. And so keeping the system where it's like we have program executions and state is either an SSA value or a side effect that can be modeled with those resources, etc. Keep the system in a way that you can describe it. You can always describe with those thing every dialect in theory, right? That was the point or the goal. And so if you
but I don't think we can do that, right? Because of the examples I showed, because you cannot conclude that those ops are semantically equivalent, even though they have the same in-memory representation. And that's why
in-memory representation. I mean, they are not pure, but to me, that's not a bug, that's a feature. Like we accurately define that IRDL ops are not pure. Because in the IRDL program,
I understand what you mean. Yes.
You know what I mean?
Yeah. So that means we're overly conservative for those things.
Yes.
Yeah.
That's the problem, though. It's like the tool we have being generic, being those side effects.
Yeah.
Doesn't allow us to write generic, very generic and simple analysis that will be very accurate.
I think I remember also now why this was ruled out, because I think the use case people presented was to determine like program equivalence in a more complicated manner. And obviously this interface shouldn't be used to determine using domain semantics, whether your entire op nest is the same and solve an undecidable problem, right? And it's also, I wouldn't want it to be used for that. Obviously the unitary stuff is a special exception, but.
So just to complement this, I would quickly did a search on Discourse and through PRs.
Oh, okay.
And there is a post from 2023 about adding an interface for CSE specifically.
For CSE specific, I didn't see that. Wow.
Yes,
Right.
I will post, like I will bump the existing thread with the old thread, which references a PR that is a rebase from the fabricator system, where
Oh,
the
wow.
original PR was approved but never merged. Then the
Ah,
updated PR was commented on, apparently pinging me, and I somehow didn't react. So we all looked at it. It was even approved. We just never merged it.
so we might
So,
actually have this feature already.
we might have had it, but we don't. So that's one thing to look at. And yes, maybe it's a question of bike shading a name and should not be called operation equivalence, but some saying like that PR specifically clearly says there's simple operation equivalence and callback operation equivalence.
Okay.
And the discussion from what I quickly saw was about that for most ops, we may want to default to op state equivalence.
Yeah.
And so we don't want all ops to necessarily implement the interface. We want them to be able to redefine it. And that's
Yeah, that's just it's that again is a problem with unregistered ops or whatever, which you don't know that they're going to change their equivalence, right? So that's why I didn't design it that way or talk about it that way, but obviously that's an option. But again, right, if we say MLIR semantics are like that, that's fine too, I think. In
Yeah.
fact, honestly, there should be interfaces that you're not allowed to do external models of. I think that would also be like a fix for the design and the maskable and masking op interface. And otherwise, you have to have the trade, right? It has to have been defined that way in the beginning. That's a bit annoying for dynamically loaded dialects, of course, but so that if you have the thing loaded the op and you see once that it doesn't have that interface, you know it will never have it. I think that would already go a long way for lots of these problems.
It's a good point, partially fixing the design problem with external interfaces. We have promised interfaces, so we can say that an op has an interface, we just haven't loaded the definition yet. But it's not like when things live in two separate projects, the interface and the op, that becomes messy. If I forget the example. I would still want to somehow move forward with this. So with like, I'm still on the side of let's just remove pure for now. We'll pessimize some optimizations, but it will be at least correct.
I think that's a good way. For vector mask, I think there's actually another trick we can do with shadowing names where we can change the op to have an index without needing to change most of the IR, but we would have to change the code it generated in that case. But yeah, that's the only one where I would be more concerned about the performance impact of like non-pure. Index one, not too much, because I don't think that's much of an issue.
You mean because this is a custom parser anyway, where the yield is implicit, and so you could add something to the parser to add something to this reduction op, like an attribute would suffice that makes it unique.
Well, or something to, well, yeah, we can do that. I was just thinking like actually the vector mask having a value, like the way you showed it sort of mean like
With the witness.
with the witness, effectively the internal argument being actually the witness of the external value masked.
Yes.
But we can still have it represented in the same way.
Oh yeah, yes, yeah.
But yeah, because the Linalg index, I'm not worried about it being marked not pure. I think that's correct, or you know. Then for now, at least, I don't think it has a big performance impact. Mask, I'm not so sure. But then again, it may be perfectly fine to start with it as, you know, not pure, and or to change it to not pure, and then if there is issue, we can adjust.
Is it sufficient or just vector mask to be not pure, or do we also have to do that for the ops inside?
No, the
Oh,
ops
sorry,
inside
no.
have to be, all the ops inside have to be.
Yes. So no, you're right. Vector mask is something we have to do something different. I think we would need to. I don't know. I don't want to say market isolated from above. That's a bit rough, but we'd have to do something. Because I don't think there's a restriction on what vector ops can be inside mask, and that means we'd have to mark all of them as not pure, which
I
doesn't
mean,
seem great.
the only ones that have semantics with mask are the ones implementing the maskable op interface, and the only
Right.
operations implementing that in upstream are a couple of the vector ops. So you just have to make those not pure, but it's like 6 or 8, so it's a lot.
And I think it's all the load store ops also.
Yeah, transfer read, transfer write.
Yeah, the thing is, I would be more on the side of having a general solution to this kind of problem and not finding one solution per pair of problematic ops or per group. So like I don't want to go and have, oh, let's fix Linalg generic by not allowing nested generic and fix GPU by having region arguments, and let's fix vector max by yet another mechanism. Because there will be yet another case where this materializes. So I would want to work towards a general fix that we document and say, if you face this problem, that's how you fix it.
I don't know what's actually I have no idea. That's why I'm asking the performance impact of adding another trait to operation equivalence.
I don't think somebody knows. So the only way to know is to add and to measure. And the way we have been historically doing that is take some big-ish IR, take the module replicated 100 times and run.
But I don't think there is a public repository of lots of big repositories with representative test loads.
No, there are no.
Yeah.
I think, well, we were at Google at the time, so we could run like big TensorFlow things. It's another good point. We should think about something like MLIR test suite.
I usually ask the Erie guys to run their benchmarks.
Good idea.
But you were just talking about a trait, but earlier you were talking about an interface, right? So
But it's kind of similar. It's just that the interface would be the solution I prefer, where I can customize everything. But then you'd have to implement on a lot of ops, unless you want to do the inversion and say you only implement the interface if you want to pessimize something, and then we get the unregistered op problem. So I think the trait is like a trade-off where you can say, okay, unitary trait, and the only thing you're allowed to say is I'm never equal, and you have to figure out everything else. And that still does a linear scan through something, right? But there is at least no dispatch over a model, right?
Yeah, I would expect that to be cheap because the linear scan you do is through like 4 pointers or something.
That's the thing. Unless we keep adding more and more traits and interfaces, and all those collections keep getting bigger and bigger, right? Yeah.
because we already look for is commutative, right? It's it haven't measured it, but I would expect just adding another trait to be quite cheap, but calling op interface method, it sounds potentially expensive. Because it happens for every op that you look at during CSE. Maybe
more of those, because it then does the hash and it goes into the table to probe it, and the hash will be the same, and it goes through, it will go through lots of those. Especially if you pessimize that, it will go through all of the ones you made unitary every time. So quadratically.
So is having a unitary trait solving all the problems?
Well, no, you're not. You can solve the correctness issues we have, but you'll still over pessimize in another direction, because then two Linalg.index operations inside one generic that could be the same are no longer the same. So it would just be a solution for like the barriers and the cases with IRDL and stuff. So we have a different specialized solution.
Or what about vectors? I think it will also.
Well, it would preclude CSE on them again, right? So
yeah, it would preclude CSE on also normal vector operations that are not masked.
Yeah, so definitely. I think that's why I say the correct solution is probably a balance of both. We need to work with the side effects better, but we also have to support the cases where those don't help because they add stuff we don't want. Again,
is something like, well, interfaces are kind of traits
yes.
as well. So, but something like,
I mean, I kind of, the whole attribute thing isn't that bad of an idea, to be honest. The annoying part is just that you have to invent, so you can solve the type variable issue, for example, by assigning a unique attribute to each of those things. That's, of course, a bit horrible with static storage duration, but you get the same thing. So you technically, we could invent one special attribute or whatever, or maybe we have one that we elevate to this purpose, like a non-attribute where we say, look, pointer equal, but they're never equal. That sounds horrible, but that could work. And it serves the same purpose as the trait, right? You just have to add something to the op that makes it unitary.
yes, but then it still doesn't solve the problem for vector masking. All right.
No, it does
might, but
solve it because you generate the attribute that you put on it depending on which operation it's in.
That requires the builders to be aware of where you put stuff. Like
That's true. Yeah. No, it's also bad.
Okay, so it sounds like we need more time to discuss this.
So I'm on the interface part, by the way. I really think that the interface is the solution I like the most and I've tried, but it is also the most hammery one, and it's the
most
not
expensive.
introspectable one. Yeah.
Okay, so maybe let's conclude on interface sounds like the most future-proof solution, but it's also more expensive. Can we find a trade-off where we minimize use of interface to minimize the cost?
The interface is also a bit ad hoc in the sense that it only tells you about are those two ops semantically equivalent. It doesn't tell more about it.
Yeah, it's not introspectable. You don't know why they're not semantically equivalent. But then, as I
you have other queries, right? It's like what are the side effect queries on those kind of thing? Like what are is it enough basically? This interface will be enough to answer are they semantically equivalent, but is this all we need basically?
So I argue for the cases we have, it is, right? But then again, the cases we have, we could also solve by making effects scopable and right.
Yes. Okay, let's iterate from here. We are running out of time. We might want to continue discussion in another meeting when we all have time. I
would volunteer just on record, right? If someone has like a test data set or something, I could make the interface and check what the compile times are, right? I could make a little interface and test how much that impacts it. If nobody else wants to invest in that solution, because right, so that we have some numbers.
Thank you. I will post some brief update on the RFC and post another poll if we can schedule yet another call to discuss this, because I think there are many good problems here, and we are. I feel like we're making progress. I don't feel like we have consensus on a solution yet.
It was good.
Okay, we are out of time. Thanks, everyone. If you have further comments, please come and comment to the RFC. Thank you, everyone.